Okay, guys, we get to get on to an easier application of things that we've been getting into. We're talking about solving, finally. We're going to solve a trig equation by kind of how we've been solving every other kind of equation, where we use algebraic techniques like collecting like terms, and factoring. The main goal in solving a trig equation is to isolate the trig function that's involved. Okay, so let's see if we can look at this one. So secant x equals 2. We also know that secant is 1 over cosine x equals 2. So if I want to solve for cosine x, I can say, well, if 1 over cosine x is 2 over 1, then cosine x equals 1 over 2. Where is cosine x equal to positive 1/2? Well, I know it's the first quadrant and the fourth quadrant where cosine equals 1/2. So how many solutions does it have? It has 1, 2 solutions. So there are 2 solutions. And if we're gonna solve this one, remember we're solving for x, but we really want to solve for cosine squared x first. So we're gonna add the 1. We end up with 2 cosine squared x equals 1. Divide the 2 away. We end up with cosine squared x equals 1/2. If I take the square root of both sides, I get regular cosine x equals plus or minus 1 root of 1/2, which is equivalent to plus or minus 1 over root 2, which if I rationalize that, I get plus or minus the root 2 over 2. So think about where all of that can happen. So cosine being positive or negative can happen in every single quadrant. So we know those solutions happen where cosine is root 2 over 2. And in every single quadrant, that's a 45-degree angle. And then from there, we can find those specific angles where theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And each of those can go on forever. So we actually say it's going to be pi over 4 plus pi n, which means it can go forever. 3 pi over 4 plus pi n, 5 pi over 4 plus pi n, and 7 pi over 4 plus pi n. Okay? To solve an equation where 2 or more trig functions occur, what you're going to do is you're going to collect the terms to one side and try to separate the functions, or by using appropriate identities. So these are going to be the same identities that we've been using. Okay, so let's give an example of a trig equation of a quadratic type. So there's lots of different answers, but one example is, remember, a quadratic means something x to the squared usually. So if I had cosine squared x plus 4 cosine x plus 4 equals 0. This looks a lot like x squared plus 4x plus 4 equals 0 as well. The only difference is that instead of x, it's cosine x. Okay? To solve a trig quadratic, we can either factor or use the quadratic formula, just like we would if it was any quadratic equation. Okay? So for example 2, and we're going to solve tangent squared plus 2 tangent minus 1. Just another way to do this, we could say let tangent x equal u. So this could be written as u squared plus 2u plus 1, because if I'm adding that 1 over, I can factor this and get u plus 1 equals 0. Well, remember, u isn't really u, it's tangent plus 1 equals 0. Well, then that means every parentheses can be set equal to 0. So if tangent plus 1 equals 0, subtract the 1. Where does tangent x equal -1? So we can take the inverse tangent of both sides to get x by itself. So we get x equals inverse tan of -1. So we know tangent is -1, where tangent is negative, so that'd be here and here, at a 45-degree angle. So we'd say that's at pi over 4 and 7 pi over 4, but remember we can go around that circle many times, so really x equals pi over 4 plus however many times around the circle we want to go, or 7 pi over 4 plus pi n. Okay? So be careful. Care must be taken when squaring each side of a trig equation of the quadratic, because this procedure can introduce extraneous solutions. So extraneous just means extra solutions that we don't need. So we have to check, or extraneous means they're solutions, but when you plug them back in, they don't work. So check to make sure that when plugged back in, it still works. Okay. And then if we have functions using multiple angles, we could have something like tangent 4x. That means tangent of an unknown angle 4 times. Okay, so like this one, we're going to solve sine 4x equals root 2 over 2. So remember, we're going to solve for, just pretend like this is just the variable that we're looking for. So to get sine off of there, we're going to take the inverse sine of both sides, cancel, and we get 4x equals the inverse sine of root 2 over 2. Well, what's the inverse sine of root 2 over 2? Where is sine positive? And we know that's here and here, where sine equals root 2 over 2. Well, that's a 45-degree, or pi over 4. So this is pi over 4, and this one's going to be 3 pi over 4. So 4x equals either pi over 4 plus pi n, or 3 pi over 4 plus, 2 pi n, because it's sine. But remember, we're solving for x. We're going to divide everything by 4. Okay? And then our last example says we're going to use inverse functions to solve. So inverse functions mean we're going to treat tangent. We can also say let tangent x equal u. So this is like saying u squared plus 4u plus 4. How would I factor that? I'd get u plus 2 and u plus 2. Well, that u is really tangent, so we're going to replace it with tangent. And then we're going to solve. I know that means I know both of these, tangent x plus 2 equals 0. Well, subtract the 2. Where does tangent of x equal -2? So we're going to use inverse tangent. You're going to plug that into your calculator. And we get x equals inverse tangent of -2. But remember, it happens every tangent is a period of pi, so it's going to be pi n. And you can plug that into your calculator, or you can leave it just like that. That's all for now. See you on Monday.